You may have heard about binary being ones and zeros, or just robot computer stuff. Binary is actually built into systems we use all the time. Imagine a light switch. It's either on or it's off. That's binary at its simplest. Remember opposite day? Trying to find the opposite of everything possible? It's a popular example of binary logic, and seeing just how many things operate with only two choices. But of course, life is usually more complicated than yes or no. Turns out, binary logic is a useful tool. If we start stringing our choices together, we can store more complex information. All starting from electric signals. The base structure provides a system to help us use numbers. With base 10, we can tell time, count money, as we add value, the place value gets full, and we must shift its position to a new place value. Computers use base 2, with our two binary digits, 0 and 1. The number 2 must be represented here as 1, 0. Just like in base 10, the place value gets full, and we must move to a new place value. Computers go through place values a lot faster since they only take 2 digits to get filled. It really comes down to storage. Binary digits are called bits. You only need 1 digit space to store a bit. 2 digits can store what's called a crumb, 4 digits a nibble, and 8 digits a byte. Computers usually work in bytes. You may see the number 1 printed as 00000001. These are called leading zeros, and they're just there to tell you we're working within the realm of a byte. Turns out, byte by byte, we can do a lot. Binary is used to store not just numbers, but all sorts of characters. First, it needs to be coded into a number system, where A equals 1, B equals 2, and so on. These are all known as ASCII in the United States. Turns out, ASCII's 128 characters was not enough for all languages, so a new system developed called Unicode. Unicode can handle characters from all over the world, including emojis. We use binary to store information inside lines or squares. A barcode is a series of lines that can be read by a scanner. The scanner uses the light-dark pattern to tell what the item is, how much it costs, and other information. Each line represents a binary value. A QR code is similar. but uses squares instead of lines. QR codes are also more powerful than barcodes since they can be recognized at any angle and repeat information in multiple areas around the code in case some areas get smudged or damaged. To show anything on screens, we use tiny squares of colored light, or pixels. In my previous video titled How Do Digital Images Work, I explained how pixels light up in a million different colors, all stored as bits. An image, at its simplest, is a bitmap, which means a map of bits. Computers decide what part of an image is light or dark by setting a rule. If it's lighter than a certain point, it turns white. And if it's darker, it turns black. This simplifies the image into a bunch of black and white pixels, making it easy for computers to understand. Computers can also look at a bitmap, scanning the pixels to find sudden differences in the values that are likely to represent an edge in an image. AI's ability to identify objects in images and videos is built on this technique known as edge detection. The next level up from a bitmap would be adding grayscale and color pixel values, where each pixel goes from 1 bit to 1 byte. Put images together in a sequence, and you start making videos. Binary may seem simple, but from this logic, we create the complex digital world around us.